Dear students, today we are going to find how to fit a normal distribution by using a problem. Solve the problem using a normal distribution. The given problem is the interval is 60 to 62 and 63 to 65 and 66 to 68, 69 to 71, 72 to 74. The length of this interval is 3. These are the frequencies 5, 18, 42, 27, 8. So first we have to write, to solve this problem, first we have to write the middle value of this interval. So 60 and 62, middle value is 61. 63 and 65, middle value is 64. 63, 68, middle value is 67. 69 and 71, middle value is 70. 72 and 74, middle value is 73. So for all this middle value, which one is the middle value? 67. So these frequencies are given in the problem. A sum of the frequencies is 100. So D is equal to M minus A. That is middle value minus this value A. This value is considered as A. So 61 minus 67, that is minus 6. 64 minus 67, that is minus 3. 67 minus 67, 0. 17 minus 67, 3. 73 minus 67, that is 6. So D bar is equal D by I. This D by I means length of the interval. Length of the interval is 3. So minus 6 by 3, 2. Minus 3 by 3, minus 1. 0 by 3, 0. 3 by 3, 1. 6 by 3, 2. F into D dash. That means the given frequency into this D dash. D dash is this values. So 5 into minus 2. 18 into minus 1. 42 into 0. 27 into 1, 27. 8 into 2, 16. So sum of your FD dash is minus 15. So again by squaring this, 2 square 4, 4 into 5, 20. 18 into minus 1 square 1, 18. 42 into 0 square 0. 27 into 1 square 27. 8 into 4, 32. By adding all this, we can get 97. So we have a formula, x bar is equal A plus summation FD dash by summation F into I. So A is the 67 here. So summation FD dash value is 15 by summation F, sum of all frequencies is 100 into length of the interval, that is 67 plus 0.45, that is 67.45. So this is the mean formula, and standard deviation formula is square root of summation FD dash square by summation F minus summation FD dash by summation F whole square into I. Summation FD dash is 100 by 97 by 100 minus 15 by 100 whole square into I. That is 0.97 minus 0.0225 into 3. By subtracting this, we can get, and applying the root, 0.973 into 3, that is 2.92. So we already calculated mean and standard deviation. So for this class interval, so we have to decrease one half point, 0.5, and increase that 0.5 here. Here we have to decrease. Here starting ending value is 62, but here starting value is 63. We have to make the interval having starting value, ending value in the before interval, and starting value in the after interval must be same. That is ending value in the before interval, starting value in the after. To get that similarity, so we have to decrease half point here and increase the half point here. You have to decrease half point here and increase the half point here. So like that. So that is become 59.5 and 62.5 and 62.5, 65.5. So here we have to decrease half point. Then we get 59.5. Here we have to increase half. That is 62.5. So like that we calculated the in class interval. So we have to write the lower limits. What are the lower limits? 50. Here observe, here the ending point is 62.5, starting point is 62.5. Ending point 65.5, starting point 65.5. Like that we calculated. So lower limits, we can write lower limits 59.5, 62.5, 65.5, 68.5, 71.5. So next we have to calculate Z. Z is equal to x minus m by sigma. That is x value is 59.5 minus as mean or x bar. X bar means mean 67.45 by 2.92. So by subtracting this, minus 2.6. So similarly 62.5 minus mean by sigma, 67.5 minus mean by sigma, 68.5 minus mean by sigma, and 71.5 minus mean by sigma. So here also we can calculate 74. So here the lower limit, next interval lower limit is 74.5. So 74.5 minus mean by sigma value is 2.49. It will be used in later. So area under the normal curve 2.72. This value, area of this value we can find from the table. So 2.7 column wise, 0.02 row wise. The value is 0.4967. So these values are get from the normal distribution table. So we already discussed how to find the area of a given Z. So these values are get from the normal distribution table. Area for each class can be obtained by subtracting 0.4967 minus 0.4554. We will get 0.0413. So again this value minus this value, this value minus this value, again this value minus this value, this value minus this value. So we can calculate. So after finding these values, we can multiply these values with the sum of the frequencies, that is summation f. Summation f is denoted by n into this value, that is 0.0413 into 100, that is 4.13, that is approximately 4 into 100, that is 20.68, approximately 21. So this value into 100, 38.92, that is approximately 39. So this value multiplied with 100, we will get 27.71, approximately 28. So this value multiplied with 100, 7.43, that is approximately 7. These are the values obtained by multiplying with the frequency.